Okay, good morning, everyone. Again, my name is Norio Kobayashi. I am a product specialist of HORIBA, and thank you for your time to attend this webinar session. And the 5000, and the 5000 is the CEMS analyzer measured mainly sold in Asia, and then now we're trying to start this business with United States right now. Um, right now I'm showing the last our regional sales manager, the Lance Isaac, and the Mick Dolmeyer, and myself Norio Kobayashi here, and with the information of the cell phone number and the email address. And please put your microphone on mute so that we can make a webinar without any background noise. And if you have a question, you can type into the chat box so that we can address those questions after the session. So let's get started. Before we go over the presentation, let me try to tell you about the social media status. We have a YouTube channels. It's showing the previous webinar sessions, and we have Facebook and LinkedIn, mainly showing the latest activities, and also Twitter and Instagram. So please follow us, and you can subscribe us. Then you can always be noticed with our latest information. Here is agenda. Who is HORIBA and the Houston facility, and also we're going to show you what the main product we have. And after that, we are going to cover the HORIBA and the 5000 CEMS analyzer. And after all of the session, we are going to cover the Q&A session. HORIBA company is built in 1957, 53, and has more than 6 years history. And HORIBA has many locations, as you can see that in the world map. And the headquarters is located in Japan, Kyoto, and we're mainly doing the business for the analysis and the measurement technology background. We have 7,149 employees, and we have 49 global locations. We're making almost $2 billion US in the sales wide. HORIBA consists of the 5 segments from automotive test system, the process environmental system, the medical, the semiconductor, and the scientific. Every division is related to the analysis. Excuse me. For example, automotive test system, we are doing the emission monitoring from the car manufacturers' vehicle emissions. So every car manufacturer has responsibility to its own emission gases, and we have 80% of the market share in this field, and also we have a big market share in the semiconductor. And process environmental is the one of the segment we are belonging to, and we are doing the manufacturing the continuous emission monitoring systems and all the process gas monitoring system or ambient air monitoring system. So we have analyzer company and doing the integration business as well. Let me talk to you about America. We have more than 16 locations in the United States, and our headquarters is located in Irvine, California, and we have just opened that HORIBA Houston in HORIBA Houston, Pasadena, Texas, back in 2018, and which is a larger facility, and where we can build all of the sample system and modern analyzers, such as like analyzer shelter. All of the integration can be done here. Let me tell you about HORIBA Houston a little bit more. We acquired the former Cameron Process company, which is the founded in 1985, and we purchased that company back in 2012, and our new construction was done successfully in 2018 with a larger building, and we have 100% HORIBA employees to build all of the analyzer shelter integration and all of the manufacturing of the analyzers. We have CAD designers, project managers, electricians, mechanical engineers, manufacturing people here. Here is the scope of work we have done with HORIBA Houston, and not only analyzer, we do the analyzer shelters, such as the picture on the left here. And HORIBA provides total turnkey solution for analyzer shelters, including engineering, design, fabrication, and the project documentation. The field service embedded service contract is another thing we are offering to the customers. We're doing the field installation and the startup and commissioning and ongoing maintenance and support. We also offer long-term embedded service technician contract and turnkey installation and demolitions. Relative accuracy test audit is the thing. We have the trailer with the analyzers go to the customer site and perform the rata testing for the CEMS users. Here is the picture so that you can see that's how wide capability we have. We do the sample system construction and the rack construction and the HORIBA analyzer integration and the non-HORIBA analyzer integration as well, and process electrical mechanical integration. I want to just emphasize it. We are HORIBA analyzer manufacturer. However, we integrate all of the analyzers into our system. We build our own sample system to guarantee the best performance for those clients' analyzers. So any project related to the analyzer process, gas analysis, something like that, we are happy to help with that project. All right, this is the product list we have in the States. Process gas analyzer, trace gas monitor for GA370, ambient air monitor, and another process gas analyzer, the VA5000, and a portable gas analyzer PG300 series, and right here the CEMS, ENDA-5000, and the ENDA-5000 stack gas monitors. We have the many webinars to cover those products introduction. So if you have a chance, search the HORIBA process and environment on YouTube and find ourselves and subscribe it. Okay, so I'd like to show you the more detail about the ENDA-5000, especially for waste incinerator application. Today the session is in the CEMS analyzer, and the content are very basic, even for who doesn't know the CEMS analyzer. But we're going to covering what the CEMS is look like, and each features and functions. Even today we are going to talk about the ENDA-5000 series. However, HORIBA also has ENDA-5000 series. I just bring these slides to avoid confusion here, because both ENDA is developed for continuous emission monitoring system, which is called the CEMS. This slide is showing comparison table. As you can see, ENDA-5000 only has NDIR analysis and MPaO2, while ENDA-5000 has chemiluminescence NOx analyzer and the UV SO2. Right here, ENDA-5000 doesn't have chemiluminescence and UV SO2, and also it doesn't have ammonia here. So because of the chemiluminescence or UV, ENDA-5000 can detect lower concentrations. Okay, let's see. So ENDA-5000 can do the 5 ppm analysis for NOx and the 10 ppm analysis for SO2, and because of the chemiluminescence and the UV, and even NDIR, while ENDA-5000 can do the 100 ppm range for CO, but ENDA-7000 can do the 5 ppm CO. So obviously ENDA-5000 has higher resolution, but you know, and also ENDA-7000 can do up to 6 components, including ammonia. So the question is, what is the future of ENDA-5000? And basically, ENDA-5000 is less expensive than 7000 and much focused on the incinerator application. Here is the outline of ENDA-5000 features. It can measure up to 5 components at the same time, including the NOx, SO2, CO, O2, and CO2. HORIBA has a 6 years analyzer experience. So based on that experience, HORIBA developed the patented cross-flow modulation, which gives great durability of analyzers and stable performance. I will explain that later. And also the sample conditioning system is well designed for each applications, especially incinerator application is one of the difficult applications to deal with. All of the key components are made by HORIBA Japan. We take full responsibility on the system. And the ENDA-5000 series has a nice interfaces. Touch panel screen is always help to operate easily, and all maintenance parts are accessible from front side. So it is a very user-friendly design. Thanks to the design, those technical background, we are still #1 market share in Japan and Korea and other countries. So 5000 series is widely sold in worldwide, and still the people keep using that analyzers. And you know, we are focusing on the more like middle range market, which doesn't require the very high sensitive low concentration measurement. All right, for the general specification, NDIR NOx range starts from 200 ppm to 500 ppm. SO2 starts from 200 ppm to 5000 ppm, and the CO starts from 200 ppm to 5000 ppm, and CO2 is from 5 to 25%, and O2 is from 10% to 25%, which is very common specification. And you can go to the option range if you need to be measuring lower range, like 100 ppm for NOx. SO2 would be 50 ppm and 100 ppm for CO. Typical application for ENDA is incinerator and the power plant. Even if your target range don't match with your specification, with the specification brochure or this chart, please still contact HORIBA. We might have an optional range available, or another special modification can achieve your requirements. All right. This is the picture inside of the cabinet in the sample system. It is, you know, the good compact design, and I see the box in the red here. This is the zoom picture of the sample system. As you can see here, the pump and a filter and a mist catcher and a scrubber. And number 5 is protect the filter and silica gel and air filter and the NOx converter behind this, number 8. So the point I want to highlight here is that everything is designed for your ease of maintenance. So you can access everything from a front side, and which is always a better way to do it. All right, and this is just for your information. Some of the people be surprised that the HORIBA is manufacturing every key parameters, key components. The picture is from HORIBA Japan headquarters located in Kyoto. Key components such as detectors, optical filters, the light sources are built and manufactured, and we age them and controlled by HORIBA employees. And we have been doing this for 60 years and still keep doing. In this way, we can guarantee the system performance, and even we can still improve in each area. So we know what we are doing, and we know what you need to do with analysis. All right, so let's talk about today's topic, the major application for ENDA-5000, which is municipal incinerator. All right, take a look at the waste incineration process. This is one of the simplest flowchart. The garbage bunker to feed the garbage into the combustion unit. And since what you are burning in is municipal waste, and you can expect a lot of dust comes from the combustion unit, and then you need to treat the sample gas to reduce the dust, NOx amount or SO2 amount or in emission gas, or maybe you need to treat additional harmful components from the gas. For the emission gas analyzer, the waste incinerator process gas is well known as high dust contains and highly corrosive gas, and it contains a rich water vapor, liquid solubility, and acid dew point, and high temperature. Those are the features of the gas from the incineration. Analyzer is required to be durable enough for those sample gas measurement, and the sample handling system needs to be well built to deal with those gas. So here is the I'm gonna explain about the issues for all of the CEMS players. Let me explain that what gas look like. The emission monitoring the waste incinerator typically brings several challenges. The sample gases includes everything from daily waste to acid-based materials. The sample gas commonly contain highly corrosive gases and also high moisture concentration, rich water vapor. And HORIBA answer is HORIBA to provide the proper sampling system and the analyzers to accurately monitor emissions over an extended lifetime. And this is one of the tables showing example of the gas condition from an incinerator. You can see that's the much SO2, or sometimes you have HCl or HF, the harmful the components inside. Okay, let's take a look how we can resolve the problem of the rich water vapor and a corrosive gas, things like that. So first of all, I'm taking a look at how we treat this rich water vapor. The table here it simply shows a higher temperature can hold much water in the gas. So this is why you want to keep that gas hot to keep the vapor state. And the cooling gas in the sampling system to knock the moisture out. So by doing this, we can drop the moisture and the sample gas can be dry. But sometimes, somebody may ask, you want to measure SO2, but SO2 is very soluble, so that the measurement data for SO2 from your device could be less. So what you're going to do? Yes, that's true, but that's why we need to minimize the dissolving SO2 while SO2 gas is traveling from the sample import point to the analyzer. I will explain how we do. So let's talk about how SO2 can be resolved into the water. Okay. This chart is showing the relationship of SO2 solubility and H2O vapor pressure curve with the temperature. So vertical axis on the left is SO2 solubility, and the vertical axis on the right is H2O vapor pressure. And the horizontal axis right here is temperature. So as you can see, in the blue line right here, excuse me. I just reboots the PowerPoint. I'm sorry. Just my computer just get freezing. Okay, I'm opening it. Hold on. Let me see. Okay. Can you see my shared screen? Let's see. Yeah, looks like it's on. Sorry for keeping waiting for it. So what I was explaining was about this picture. And as you can see, this blue line and higher temperature can contain much vapor, as you know. And okay, let's take a look at SO2 solubility here. When it is low temperature, this area, like 10 degrees C or 0 degrees C, you have much SO2 is soluble. And as the temperature goes up, the solubility gets lower. So this is telling something right now. If SO2 touched cold water, right? If SO2 touched the cold water, you will lose a lot of SO2. And if SO2 touch the warm water, you will lose less SO2. If you cool the sample gas rapidly, then you expect a lot of water comes out. And that cold water will capture a lot of SO2. With that being said, HORIBA provides three steps dehumidifier system. Oh. So there are three steps to cool water at the 40 degrees C and 20 degrees C and 5 degrees C. When you cool the gas at the 40 degrees C, you expect that majority of water comes out, which is more than 50%. And in this temperature, still SO2 solubility is low. And in the second step, the ENDA system cool the sample gas at 20 degrees C, and the amount of water is much less compared with the one at 40 degrees C. Even SO2 solubility is a little bit higher, amount of water is less, which means you don't lose SO2 much. Lastly, the cooler setting is at 5 degrees C, then the system will drop the rest of the moisture out. So 3 steps dehumidification system is consist of the drain separator, the pre-cooler unit, and the main cooler. With this sampling system, we achieve to minimize the loss of SO2 and NO2. Also, trouble of drain is reduced drastically because cooler unit does not have to deal with that much moisture at the time. So the system is durable enough to deal with the gas contains sample gas which contains up to 40% of moisture. The other issue, the sample gas is highly corrosive. Since incinerator application likely contains the gas such as HCl, HF, SO3, etc. Those are highly corrosive, and it will rust or damage the parts in the sample gas sample system or analyzer itself. From this section, I will talk about technology, how the analyzer can be durable, and the other one is the sample system, how we can get rid of those unwanted components. First of all, I'm going to talk about the HORIBA patented cross-flow modulation technology. This is the picture is conventional NDIR method. Basically, it has the light source and the sample gas, the sample cell, the 2 light source and a 2 light sample cell, and 2 detectors right here. And a sample gas travel from the inlet and to outlet, right? And what you're looking at here is detector is looking at how much reduction could occur while you're traveling from this path. So your detector on the reference cell is looking at always 0 reduction of the power, 0 absorption of the light power. And this detector is looking at some absorption because the sample gas will capture the light power. Yeah, this is the one of the way for the conventional method, but there's a problem, which is you are not sure 2 light source has always same performance, and the 2 detector has always same sensitivity. So you will need to do that, optical adjustment. And also, you will keep introducing the dirty sample gas into the sample cell, which will keep, rusting inside of the cell, which causes the another drift. And drift needs optical adjustment. And like I said, the balance of light source power and the sensitivity of the detectors need to be corrected. So one of the guy developed another way, which is the 1 light source in the 1 detector. The light path comes from split like this. And but still we have a problem of this dirty sample gas kept introduced into the this sample cell, and which will damage into the sample cell and causing the drift. And drift needs optical adjustment. And also another problem is because you need to split the light power 50% by 50%, but if you're in a plant, you will see some, a lot of vibration there. There's a lot of noise, and that will affect on this division. So HORIBA developed the one of the way, which consists of the 1 light source, the 1 measurement cell, and the 1 detector. And the light, sample gas, reference gas, going to be introduced like this, and right after that, sample gas gonna be introduced like this. So we are alternately introducing the reference gas and the sample gas, reference gas, sample gas every second. So which means you are always looking at the zero. Right after that, you are looking at the sample, which is span, right? So you are doing kind of the virtual, like a zero calibration every second, which means um, you don't have any zero drift anymore, which means you don't have to have any optical adjustment anymore. So this is great feature to give us stable measurement. And also you have the reference gas every second, which helps to purge inside of the cell. So while you sample gas into the measurement cell, right after that, you will introduce the reference gas into the cell and purge inside. So that will keep clean inside of the measurement cell, which lifetime longer than anybody else. So that's automatic cleaning, purging for cell is one of the great great work for this measurement unit. And HORIBA designed the detectors with much beam splitter, and light source goes travel like this. The each split light reach to the each detectors. So the one optical unit makes 4-parameter analysis. So here is a CO2 measurement detector, and a NOx, SO2, and a CO, things like that. So just only one optical unit makes 4-parameter analysis, which is great. And this reduces the amount of the parts and realize better performance frequency. So another things for the O2 analysis, this is simple schematics to show you how it works. The sample gas flow like this from inside to out, right? And oxygen has a feature to be attracted by a magnet. So while magnet is off, O2 is not attracted to the magnet, so just sample goes flow from the inlet to outlet, right? And when an electromagnet is on, O2 starts being attracted to the magnet right here, and this causes some pressure increasing inside of chamber right here, and this pressure bend the membrane, and the degree of bending of the micromembrane is related to the O2 concentration. As you can see, the beauty of this method is because detector right here doesn't touch the sample, so it won't have any damage or corrosion from the sample gas, even your sample gas may contains HF or HCl or Cl2, SO3. There's a lot of corrosion gas could be included in the sample gas from incinerator, but you don't, your detector doesn't touch that sample gas. There's no physical contact with it. So with that being said, magnet MPa O2 analysis has great stability and a longer lifetime. Okay, in a sample conditioning system, also we need to deal with those corrosive gas, and ideally we need to get rid of all of harmful corrosive gas in a sample system. So we want to carry the sample gas into the analyzer. That gas should be clean as much as we can. So the sample gas conditioning system will work for it. HORIBA provides the mister catcher to capture the SO3. This is SO3 mister catcher, and there's a couple of types of the model of the SO3 mister catcher. Depends on the concentration of SO3. If you have more capacity, you're gonna need more bigger mister catcher. SO3 is extremely corrosive, and once it comes into the analyzer cell gets rust. So analyzer will be very difficult to keep its performance in this case. So HORIBA provides this miscatcher as standard configuration. And the halogen scrubber, especially incinerator application, you need to get rid of this CO2, HCl, HF, etc. And the halogen scrubber works to remove those corrosive gases. Like I explained, halogen scrubber has a different, the model depends on the concentration of the sample gas. Here is the flow schematics for ENDA-5000 series. As you can see, here is the drain separator and the cooler unit, and also another cooler unit right here. So these three steps cooler unit is dehumidifying the moisture out, and the scrubber and NOx scrubber in the mist catcher will capture the unwanted components such as SO3 or HF and HCl, stuff like that. All right, and this is the system overview. We carefully choose the right ports for your applications. Sampling probe with filter, and depends on your application, material may change. We consider the configuration and material of sampling tubes. Depends on the NO2 concentration in your sample. We provide bigger NOx converter, right here. And depends on the SO3 concentration. We pick the suitable size of the mist catcher. Also, the other options like halogen scrubber, CO2 scrubber is going to be picked, different design of drain separator, etc. Yes, it is our job to propose you with the best sampling system for your analyzers. Okay, let's wrap up here. The issue of waste incinerator is rich water vapor, and the gases are soluble, and the sample gas is highly corrosive. And the HORIBA countermeasures are 3 steps dehumidification, and the cross-flow modulation for NDIR, and magneto-pneumatic analyzer MPA for O2. Those technology will prevent the corrosive, the rusting inside of the unit. And mist catcher and halogen scrubber sample system will deal with those corrosive gases. So that is the HORIBA answer to these issues. So let me summarize why you want to choose HORIBA here. Our mission is to realize long-term stable measurement and keep you in compliance. We can make it happen because, ENDA has we have 60 years of experience on sample gas condition system and analyzers. Because we have a patented cross-flow modulation, and because we are a manufacturer, we have take all of the responsibility on your parts, and we build them. And we have excellent service support nationwide. That's what we're offering you guys. So I think that is it pretty much. Thank you for your time, and I am happy to answer the question. Let's see. Let me see the chat box. Okay, I got one question. O2 in stack is normally between 3 to 5%, 10 to 25%. Which and the measuring range is unusual. Yeah, I mean, even O2 stack is 3 to 5%. That's fine. We can set up the 10% measurement range. Doesn't mean you cannot measure 3% or 5%. It's very common to measure those concentration. Okay, another question is lead time. Normally, we build an analyzers. We start the building, manufacturing the system after PO and a kickoff meeting, and that will takes 12 weeks to the 16 weeks to deliver. All right. And another question, can remote calibration be done? Yes, ENDA-5000 can accept or model bus communication with the external PLC or just digital contact input, and that will initiate the calibration. And question is, what is the maximum probe length from flare stack to analyzer? Is there any venturi inside the probe inlet? The length of the probe, I think you were talking about nozzle. It could be 1.5 meters and 2 meters or 3 meters, depends on the applications. We are flexible on this. So if you have a specific the request, then we can design that. Okay. All right, you guys, any other questions? Okay, I think that's it from my side. Again, appreciate for your time and for your business, and we are open to discuss any subject about the analyzer and the problem and the site. And then we also do the a lot of the field service too. So anything the project to upgrade the building sample system or buying the analyzer, please contact regional sales manager Lance or Mick or myself. Okay, appreciate it. Thank you so for your time.